Hello, this is Mr. McGovern. We are looking at the second video in the constant velocity series where we're looking at two new concepts, displacement and distance, and giving definitions to both of them. So we've got a red car that we had from our last video, and the little racetrack it's on now, I've given some precise measurements so we can look in more detail about where it's moved to. So one of the last things we did in the last video was we changed the idea of having a distance time graph to a position time graph, and we changed that symbol D to position X. It is more useful to talk about an object's position. Right, so the red car starts at the 0 position and moves to the 100 meters over a time period here, and this is the graph we've got of it here. We only really need its starting point, its starting position, and its final position, 100 meters, to work out how far it's gone. It's gone from 0 to 100 meters. What if we had a more complicated situation? We had the green car here, starts at the starting position, moves forward to 40, then moves back 20 meters, and then moves forward again to 100. The graph for that would look a little bit more complicated. Moves forward to 40, back to 20, and then forward again to 100. Now, with the green car, we can still say it started at 0 and it finished at 100. It's changed its position by 100 meters. Yes, that's still true, the same as the red car. But also some complicated things have happened in the middle of its journey. So we kind of need two different definitions to deal with these situations. So we know that both cars start at 0 and they finish at 100 meters. Both of them, their position change is the same. So change in position is X. The symbol in physics for change is the triangle there, which is the Greek letter delta. So I can sometimes say triangle X, sometimes I'll say delta X. Both of them mean the same thing, change in position. And the way we work that out is we just need the final position and the initial position, subtract the two. So we were, in both cases, we've ended at 100 meters, we started at 0 meters, 100 minus 0 is 100 meters. This is our first definition, displacement. Displacement is the change in position. It only requires the beginning and the end. Now the green car travelled a longer path to get to their final position because they did some funny things in the middle. The path length that they actually travelled was from 0 to 40, back 20 meters, and then from the 20 to 100 is another 80 meters. So if you add those up, you get 140 meters. This is our second definition, which is distance. Distance is the path length travelled. Displacement, on the other hand, depends on initial and final positions. Distance, on the other hand, depends on the path length you travel. So two different definitions moving forward. You have to be able to understand these, and most of the time when we do our calculations moving forward, we're often going to be using displacement. Distance will crop up as well, but it's good to know the difference between the two. So displacement again is change in position. We need the final position and the initial position. Whereas distance, you need to know the path travelled all the way between those two positions.